Wastewater Math Quiz number 7. As always, these questions do not belong to me. I've pulled them off of other study guides. I answer them to the best of my ability. This presentation is for learning purposes. As always, a formula sheet is helpful and a calculator. I will read the questions first. There will be an answer slide, and then after the answer slide, I will, to the best of my ability, walk through the questions step by step. Hopefully this helps you learn. Thanks. Question 1. A trickling filter has a diameter of 109.5 feet. If the flow through the filter is 2.71 mgd and the recirculation rate is 25% of the flow rate, what is the hydraulic loading rate on a trickling filter in gallons per day per square foot? Is it A, 298 gallons per day per square foot, B, 360 gallons per day per square foot, C, 412 gallons per day per square foot, or D, 327 gallons per day per square foot? Question 2. What is the solids loading rate in pounds of solids per day per square foot given the following data? Secondary clarifier radius 34.95 feet. Primary effluent flow 1.22 mgd. Return of activated sludge is 0.65 mgd. Mixed liquor suspended solids is equal to 3,060 milligrams per liter. Specific gravity of the solids is 1.03. Is it A, 11.4 pounds per day per square foot, B, 12.4 pounds per day per square foot, C, 12.8 pounds per day per square foot, or D, 13.4 pounds per day per square foot? Question 3. What is the hydraulic loading rate for a pond that is 17.3 acre-feet in gallons per day per square foot if the flow into the pond is 4.06 mgd? Is it A, 6.45 gallons per day per square foot, B, 5.38 gallons per day per square foot, C, 4.92 gallons per day per square foot, or D, 7.10 gallons per day per square foot? Question 4. If a polymer pump is delivering 12.3 gallons per day, what is the feed rate in milliliters per minute? A, 25.6 milliliters per minute, B, 32.3 milliliters per minute, C, 41.8 milliliters per minute, or D, 52.7 milliliters per minute? Question 5. Given the following data, determine the amount of primary dry solids produced in pounds per day. The flow is 2.88 mgd. Influent suspended solids is 297 milligrams per liter. Primary effluent suspended solids is 126 milligrams per liter. A, 3,520 pounds per day. B, 4,110 pounds per day. C, 4,980 pounds per day. Or D, 5,250 pounds per day. And here we have the answer key. Question 1, B. Question 2, C. Wait, C? I wanted to make all the answers to this quiz B. Well, if you answered B for question 2, you're probably a little confused right now. Go to the walkthrough and find out why. Question 3 is B, question 4 is B, and question 5 is B. Thanks question 2 for messing it up for everybody else. Anyway, next part of the video is me solving the questions step by step. Question 1. A trickling filter has a diameter of 109.5 feet. If the flow through the filter is 2.71 mgd and the recirculation rate is 25% of the flow rate, what is the hydraulic loading rate on a trickling filter in gallons per day per square foot? All right, To find the hydraulic loading rate is equal to the total flow gallons per day divided by the surface area in square feet. So let's find that total flow first. The total flow is equal to 2.71 mgd plus 2.71 mgd times 25% as a decimal, because the recirc rate is 25% of the total flow. And we want that in gallons per day, so we're going to multiply it by a million. So we did our math in the bracket first, the 2.71 times 0.25%, and you get 0.6775 million gallons a day. So we're going to add that to the 2.71 million gallons a day. You get 3.3875 times a million to get this into gallons per day instead of million gallons a day. So you get 3,387,500. Now let's solve for surface area. So it gives us the diameter. So surface area with diameter is 0.785 times diameter squared. So you have 109.5 foot times itself, so squared, times 0.785. And you get a surface area of 9,412.3 square feet. So we can plug all this into our formula. You have a flow of 3,387,500 gallons per day divided by the surface area of 9,412.3 square feet. You do your division, and the answer is 359.9 gallons per day per square foot, which you're going to round to B, 360. Question 2. What is the solids loading rate in pounds of solids per day per square foot given the following data? Your secondary clarifier radius was 34.95 feet. Your primary effluent flow was 1.22 million gallons a day. Your return of activated sludge is 0.65 million gallons a day. Your mixed liquor suspended solids is 3,060 milligrams per liter. And your specific gravity of the solids is 1.03. The formula we want to use is the solids loading rate, pounds per day per square foot, is equal to the solids applied, pounds per day, divided by surface area in square feet. To find your solids applied pounds per day, we're going to do feed rates pound per day formula is equal to the dosage milligrams per liter times the flow million gallons a day times 8.34 pounds per gallon. And to find the surface area, and we were given a radius, to find surface area with a radius is area is equal to pi times radius squared. First, let's find the solids applied. So feed rate pounds per day, you have 3,060 milligrams per liter times the flow of 1.22 mgd plus the recirc of 0.65 mgd, and times that by 8.34 pounds per gallon. But guess what? The specific gravity of the solids is 1.03. So we're going to multiply 8.34 pounds per gallon times 1.03. If you're here because of the answer sheet, you got the answer B. It's because you didn't solve for the specific gravity. So we solve for our brackets. We get 1.87 million gallons a day when we add the 0.65 and 1.22 together. And when you multiply 8.34 times 1.03, you get 8.59 pounds per gallon. So now we can multiply that all together. 3,060 milligrams per liter times 1.87 mgd times 8.59 pounds per gallon. And the answer was 49,153.7. I decided to put it in the bracket already. Now let's solve for the area. You have pi times 34.95 squared, so times itself. So 3.14 times 34.95 times 34.95 is equal to 3,835.51 square feet. Put that in the formula. 49,153.7 pounds per day divided by 3,835.51 square feet. Do your division. And the answer is 12.81, rounded C, 12.8 pounds per day per square foot. Again, if you didn't take account for specific gravity, you would have got 12.4. But the correct answer is 12.8, C. Question 3. What is the hydraulic loading rate for a pond that is 17.3 acre-feet in gallons per day per square foot if the flow into the pond is 4.06 million gallons a day? The formula for hydraulic loading rate, gallons per day per square foot, is equal to the total flow applied, gallons per day, and the area in square feet. Well, our flow is in million gallons a day, so we're going to have to convert that to gallons per day. And our surface area is in acre feet. We're going to have to convert that to square feet. So here's how you can convert that. 4.06 million gallons in 1 day times 1 million gallons over 1 mg. Your mg's will cancel out and leave you with gallons per day. There is 43,560 square feet in an acre foot. We want the acre feet to cancel out, so 17.3 acre feet times 43,560 square feet over an acre foot. So they'll cancel out. All right, so you do your multiplication, the million gallons will cancel out, and you get 4,060,000 gallons per day. And you do 17.3 acre feet times 43,560 square feet. The acre feet cancel out, and you get 753,588 square feet. Now we can plug that into our formula. So we have 4,060,000 gallons per day divided by 753,588 square feet. You do your division, and the answer is 5.387 gallons per day per square foot. The closest answer is B, 5.38 gallons per day per square foot. Question 4. If a polymer pump is delivering 12.3 gallons per day, what is the feed rate in milliliters per minute? Well, this problem is going to be unit conversion. All right, so we start off with 12.3 gallons over a day. We're going to multiply that by 3,785 milliliters per gallon. Our gallons are going to cancel out, and then we're going to multiply that by 1 day over 1,440 minutes. Your day is on top, your day was on bottom. They cancel, and you're going to be left with milliliters per minute. So again, 12.3 gallons per day times 3,785 milliliters per gallon times 1 day over 100,440 minutes. Your answer is 32.33, or B, 32.3 milliliters per minute. Question 5 was, given the following data, determine the amount of primary dry solids produced in pounds per day. Flow, 2.88 mgd. Influent suspended solids, 297 milligrams per liter. Primary effluent suspended solids, 126 milligrams per liter. All right, so suspended solids removed pounds per day is equal to the suspended solids removed milligrams per liter times the number of million gallons a day times 8.34 pounds per gallon. To find the suspended solids removed milligrams per liter, we're going to take the influent minus the effluent. So you had 297 milligrams per liter in the influent minus the primary effluent suspended solids of 126 milligrams per liter. You do your subtraction and you get an answer of 171 milligrams per liter removed. So we can plug this into the formula. So we have 171 milligrams per liter times 2.88 million gallons a day times 8.34 pounds per gallon, multiply across, and the answer is 4,107.28. Your closest answer is going to be B, 4,110 pounds per day. And here we have finished another 5-question wastewater treatment math quiz. Hopefully this is helping you study and learn. Thanks.